Hey y'all, welcome back to the lab. In this video, we're going to be talking about how to compress web responses from F# and Giraffe endpoints. So I've recently added web response compression to several of my websites to lower their bandwidth usage. Here we'll explore how to add compression to your web responses to lower their payload size. So first we're going to talk about F# and Giraffe and the web app setup that we're using to demo this. So for our example project, we'll be using our minimal full stack F# and Giraffe web app we built previously as a foundation. We're basically just changing the endpoints and what they return. And so this web app will have a single endpoint, really just a slash. And this thing is going to create 1,000 GUIDs. It's then going to create HTML for those 1,000 GUIDs and then return the HTML to give us some sort of sizable, web response to the front end so we can actually see, what compression is doing to them. So in my example, the uncompressed version of this is about 45 kilobytes. And then with compression, we get 21 kilobytes, which is a savings of about 50% for our example. And as always, I'm just a random guy on the internet, so you shouldn't trust the code I'm showing you. So here I'm going to demo this to show you it works. So here I am in my HAMY Labs example repo. I've got open my Giraffe web compression project. I've turned off response compression by commenting this out, and I'm going to kill the web app and restart it with .NET Run. It says it's working and it's on port 5000, so we'll go over there to localhost 5000 here. Make this a little bit bigger so you can see it, and then I will reload. And so what we can see here is that, just a very simple HTML web page that we're building, total count at the top, and then we're just a list of all 1,000 GUIDs. So pretty large, but this is a pretty simple web page. So you can imagine that your web page might not have 1,000 items, but it's almost certainly going to have way more elements on it to make it actually look nicer than just this raw list. And here we can see that a request hit localhost here, and the size was about 45 kilobytes. So this is uncompressed. This takes us about 45 kilobytes. So now what we're going to do is come back over here and uncomment this line, which will tell our web app that it should use compression. We'll save this. We will kill the web server. We will run .NET Run again, wait for it to boot up. It says it's on 5000. So we'll come back over here and we'll reload our page and look at the response. And we can see that, the response is the same, just a big list of items. And then if we look at the size, it's about 21 kilobytes. So that's proof that this actually works. And then we'll dive into the code that makes this happen as well. Okay, so how to compress web responses in F# and Giraffe. So Giraffe is a thin wrapper around ASP.NET, which means we still have access to a lot of the goodies from one of the world's most popular and performant web frameworks. And here we add two configurations to our F# and Giraffe setup that allows this compression to happen. So first is we have the app use response compression. That's the line that I was commenting out to turn this on and off. And we also have to, in the services, add response compression here, I guess so that the services know how to add it. ASP.NET configuration is pretty arcane, I'll be honest. And so you kind of just have to look at the docs and be like, fine, this is what I have to do to turn this on. And together, these are going to allow our web responses to be compressed. And so here's the configuration code in my program.fs that you can look at. And really there's only two lines that we really care about. It's here, this use response compression. It is important that it comes near the top because then everything after it will be compressed. And then here in our configure services, we just have services.add response compression here. And one thing that I'm passing to it is enable for HTTPS to true. This is important for me because basically I only serve my websites on HTTPS. So if it doesn't have this, then it won't actually do anything for me. There are some caveats around like security, like because it's compressed, maybe you're not getting a full checksum on everything. But honestly, I think for most websites, this is like fine. And so I always put this to true. And then here's your standard, .NET config. So if you want to look at this, the code's here. And then also the full code for this project is in my HAMY Labs code examples project, which is available to Hominions members. So if you're interested in that, check that out here. All right, next. So that should get you set up with web compression for your endpoints. Now, I recently rolled this out on 1,000 checkboxes, which is my little checkbox clicker, kind of similar to 1,000 checkboxes. Basically, you can check a box, and it goes everywhere. Under the hood, this is actually using HTMX, which, means we're actually replacing a good bit, a full 1,000 checkboxes like every few seconds. So you can imagine that the bandwidth of that gets pretty high. In addition to that, it's using HTMX, which adds extra attributes, and Tailwind, which itself is a pretty verbose styling language, and so that makes the responses pretty large. And so if we're pulling this every like few seconds, it can quickly add up. And so by doing this, I was able to reduce my payloads by about 60% from about 100 kilobytes to 40 kilobytes, which makes me feel, a lot better about my bandwidth usage, which can get pretty pricey. I've also added web compression on by default to Cloud Seed, which is my F# project boilerplate. This is how I start all my projects, and so I like to, any best practices I find, I like to just build into the boilerplate so that every new project I have starts with it. So that's now on if you're interested in, starting your own projects here. Now, if you like this post, you might also like introducing 1,000 checkboxes, a real-time globally synced display of 1,000 checkboxes. This talks a little bit about what this site is, some of the design considerations I was thinking about, and in particular, some of the problems I was having with bandwidth. And so this can provide like a real world example of when you might want to reach for web compression, when it might make your system better off. You might also be interested in why Zig is migrating from AWS to self-hosted, bandwidth and the costs of that in the cloud being one of the main drivers of this move. And then finally, you might be interested in build a simple full stack web app with F# and Giraffe to go a bit further into the minimal example that we built this example on top of, if you want more information about that. So that's it for this video. Thanks for watching, and I'll see you in the next one.